Hello students, we are going to study the diode application in clipper circuits. Clipper circuits are also known as limiter circuits, which clips off some portion of the input AC signal without changing the shape of the input signal. There exist two combinations of clipper circuit. One is series clipper circuit, in which the diode is connected in series to the input source. The other one is shunt clipper, in which the diode is connected in parallel to the input source. Let's see the list of clippers based on series and shunt combination. The first list of clippers consisting of three circuits are namely series positive clipper, series positive clipper with positive bias, series positive clipper with negative bias. Second list of clippers are namely series negative clipper, series negative clipper with positive bias, series negative clipper with negative bias. Third list of clippers are namely shunt positive clipper, shunt positive clipper with positive bias, shunt positive clipper with negative bias. Fourth list of clippers are namely shunt negative clipper, shunt negative clipper with positive bias, and shunt negative clipper with negative bias. The first circuit is series positive clipper. Here D represents the diode, R represents the resistor, VO is the output voltage measured across the resistor. VI is the input AC voltage varying from plus V volt to minus V volt, which is fed across the AB terminal of the circuit. During the positive half cycle of the AC input, A becomes positive and B becomes negative. Diode is in reverse bias, making an open circuit across it, which ensures there is no closed path. So there is no output voltage across the resistor. During negative half cycle of the AC input, A becomes negative and B terminal becomes positive. Diode is in forward bias, making a short circuit across it, which ensures a closed path. So output voltage across the resistor will be available. For the next positive half cycle of the input, the same process is repeated. In this way, this circuit is clipping off the positive portion of the input signal. So the name series positive clipper. Let's implement this circuit. The circuit is implemented on the breadboard, where the diode and resistor are connected in series. The input is given across these two terminals and the output is taken across these two terminals. We will use function generator as the input source combination of the clipper circuits, and output will be observed on the DSO. We will consider the frequency of input signal to be around 1 kHz and its peak to peak voltage to be 15 volt and the biasing voltage to be 3 volt for positive as well as negative bias. The input, which is from the source of function generator, is given to the circuit near these two terminals, and the same input waveform will be observed in the channel 1 of DSO. And the output, which will be observed in the channel 2 of the DSO. As you can see, output is taken across the junction point of the diode and the resistor, which is fed to the channel 2 of the DSO. As you can see, channel 2, we can see the channel 2 waveform. The positive portions are clipping out. We have taken 15 volt peak to peak And if we observe the channel 2, maximum voltage is Vmax voltage is 200 millivolt. That means if we convert the millivolt to voltages, it will be 0.002 volt. That means our Vmax is 0, as we can see here, and V minimum is, we can see, minus 7.40. So in this way, this circuit is clipping off the positive portions. Let's see the second circuit, series positive clipper with positive bias. Positive bias 3 volt is connected below the resistor 1K. During the positive half cycle of the AC input, diode gets reverse biased and the bias voltage 3 volt is appearing at the output. During the negative half cycle, diode gets forward bias and a closed path is established, so the input waveform, the same input waveform is appearing at the output. In this way, this circuit is clipping off the positive portion up to the bias voltage, up to the positive bias voltage 3 volt. Now we will implement this circuit and observe the waveforms. This is the circuit implementation. Only changes made were below the resistor we have connected DC voltage of 3 volt, that is the bias voltage. The positive supply of the bias voltage is fed to the resistor end, and the negative terminal of the DC supply is connected to the common ground. These are the output waveforms of the circuit. As you can see, as I am changing the bias voltage, the output waveform is clipping to that bias voltage. As we have taken 3 volt, if we observe carefully, channel 2 is the output waveform. The maximum voltage of channel 2 is 3 volt and the minimum it is 7 volt. V minimum of channel 2, that is output, is 7 volt. So in this way, positive portion is clipping up to the positive bias voltage. Let's see the third circuit, that is series positive clipper with negative bias. The only difference is the bias voltage, the terminal, negative terminal is connected to the resistor and the other positive terminal is connected to the common ground of both input and output. During the positive half cycle, the diode gets reversed bias, so only the bias voltage -3 will be reflected at the output. As you can see, during the negative half cycle, the diode gets forward bias, a closed path is established, and the same input waveform after -3 volt will be appear at the output. We will implement this circuit and observe the waveform. This is the circuit implementation. Only difference is the negative terminal of the DC supply is given to the resistor end and the positive supply of the DC is given to the common ground. Let's see the output waveform. As you can see, the V maximum of the output is in negative, which is coming approx -2.8, and the V minimum of output is -7.4. So in this way, this circuit is clipping the positive portion up to the negative bias, which we have kept around 2.8. The second list of clipper circuit, that is series negative clipper. As you can see, this is the input waveform. At the output, the negative portions are clipped off. During the positive half cycle of the AC, the diode is in forward biased, a closed path is established, and the same input waveform is appearing at the output with plus V volt as V maximum voltage. During the negative half cycle, the diode gets reversed bias, establishing no closed path, so no output is available at that time. Now we will see the waveforms and circuit practically. Circuit connections are like this. We have taken 1K resistor and the diode kept in forward bias. If we see the output waveforms, we can see the output Vmax is coming 6.8. The total VPP, the input signal is having VPP 15.80, and the V minimum of output is almost 0. 400 milli, that means it is 0.00 volt. So this circuit is clipping the negative portions. We will see the second circuit of series negative clipper with positive bias. The biasing is connected below the resistor. During the positive half cycle of the AC input, the diode is forward biased. So same input waveform is appearing at the output up to the bias voltage, that is 3 volt. During the negative half cycle of the AC input, diode gets reverse biased. Only the 3 volt will be observed at the output. Let's see the practical implementation. Positive bias around 2 volt is connected below the resistor. The output waveforms, as we can see, channel 2 maximum voltage Vmax is coming around 7 volt, and V minimum it is coming around 2.8 volt. So in this way, this circuit is clipping the negative portion up to positive bias voltage, that is 3 volt. The third circuit, series negative clipper with negative bias minus 3 volt. Negative bias is connected to below the resistor R. During the positive half cycle of the AC input, diode is in forward bias. Same input waveform will be observed at the output. During the negative half cycle, diode gets reversed bias. No closed path is established. Only the bias voltage, that is minus 3, will appear at the output. Hence the output has Vmax 7.5 volt and V minimum minus 3 volt. Let's observe the waveforms. Circuit implementation. The negative terminal of the DC is connected below the resistor, and the positive of the DC is connected to ground, all common ground. As we can see, the output V maximum is 6.6 and the V minimum is minus 3.4. In this way, this circuit is clipping the negative portions up to minus 3 volt. Let's study and implement the third list of clippers, shunt positive clipper. During the positive half cycle of the AC input, diode gets forward bias. It acts as a short circuit the potential measured across the diode will be 0, hence no voltage during the positive half cycle. During the negative half cycle, diode gets reversed bias. There will be a open circuit. So, same input waveform will be observed at the output. V minimum of the output will be minus 7.5 and V maximum will be 0 volt. Let's observe the waveforms. The circuit implementation. Input is supplied to the one end of the resistor. Output is taken at the junction of resistor and diode, and the negative or the grounding is given to the cathode of the diode. As we can see, channel 2 Vmax, which is our output, which is coming across 800 millivolt, that is 0 volt, and channel 2 V minimum is minus 8 volt. Here it is 0 and here it is minus 8 volt. In this way it is clipping of the positive portions. So the name shunt positive clipper. The second circuit, shunt positive clipper with positive voltage 3 volt is connected below the diode. During the positive half cycle of the AC input, diode becomes forward bias. Short circuit is established here. Measure the output across this terminal will be 3 volt, which is appearing at the output. During the negative half cycle of the AC input, the diode is reverse biased and open circuit is established. Hence, the output will have the same input voltage during that period, that is negative half cycle. So Vmax of output is plus 3 volt, V minimum is minus 7.5 volt. Let's observe the waveform. The circuit connection is like this. Positive of the DC supply is connected to one end of the diode and the negative of the DC is connected to all common ground. Observing the waveform, we can see that the V maximum of channel 2 is 3.6 and V minimum of channel 2 is minus 8 volt. This circuit is clipping the positive portions up to positive 3 volt. The third circuit, shunt positive clipper with negative bias, that is minus 3 volt. Negative terminal of the bias voltage is connected to the cathode of the diode and the positive of the bias voltage is connected to all common ground. During the positive half cycle of the AC, diode is forward bias. A short circuit is established. Hence, the output will have minus 3 volt. During the negative half cycle, the diode is reverse biased. It is an open circuit. So, whole input waveform will be appearing at the output up to after minus 3 volt. The maximum V maximum of the output will be minus 3 volt. V minimum of the output will be minus 7.5 volt. Let's observe the waveforms. The circuit connections are like this. The negative terminal of the bias voltage is connected to the cathode of the diode and the positive of the bias voltage is connected to the all common ground. If we observe the waveforms, channel 2 V maximum is minus 2.2 and the V minimum is minus 8 volt. So this circuit is clipping the positive portions up to minus 3 volt. Let's study and implement fourth list of clippers, shunt negative clipper. During the positive half cycle of the AC input, diode is reverse biased, so an open circuit is established across the diode. So whole input waveform will appear at the output. During the negative half cycle, the diode gets forward bias, a short circuit is established, hence no voltage will appear across the diode. So the Vmax of the output is 7.5 volt and V minimum is 0 volt. Let's implement this circuit and observe the waveforms. The circuit connections are like this. The only difference is the diode is made in reversed bias. Observing the waveforms, we can see the Vmax of the output is 7.4 and V minimum is minus 800 millivolt, that is 0 volt. So in this way this circuit is clipping the negative portions. So the name shunt negative clipper, as the diode is connected in parallel to the input. The second circuit, shunt negative clipper with positive bias. The positive bias 3 volt is connected below the diode, plus DC polarity is connected to the anode of the diode, and the minus polarity of the bias voltage is connected to the all common ground. During the positive half cycle of the AC, diode is reversed bias, hence a closed path will be available here. So whole input waveform will be appearing up to plus 3 volt. During the negative half cycle of the AC input, diode is in forward bias, a short circuit is established, hence the output will have plus 3 volt. So V maximum of the output waveform will be 7.5 volt and V minimum will be plus 3 volt. The circuit connections are like this. The DC bias voltage of positive 1 is connected to anode of the diode, and the negative of the DC bias voltage is connected to all common ground. As you can see, the output waveforms are like this. If we observe, the Vmax voltage of output is 8 volt and V minimum is coming around 2.20 volt. So in this way, this clipper circuit is clipping the negative portion up to the positive bias voltage, which we had given 3 volt. The shunt negative clipper with negative bias, the negative terminal of the bias voltage is connected to the anode of the diode, and the positive of the DC bias voltage is connected to all common ground. During the positive half cycle of the AC input, the diode is in reverse biased, so it is an open circuit, hence the output will have the whole input waveform. During the negative half cycle of the AC input, the diode is in forward bias, a short circuit is established here, so at the output we will have minus 3 DC bias voltage. In this way, the output maximum will be 7.5 voltage and V minimum will be minus 3 voltage. The negative of the DC is connected to the anode of the diode and positive is connected to the all common ground. The output waveforms we can see, the V maximum is 8 volt and the V minimum is coming around minus 3.8. So in this way, this circuit is clipping the negative portion up to the negative bias voltage, which is minus 3 volt. Here it is minus 3.6 volt. In this way, we have studied and observed all the combination of clipper circuits.